Hello, I'm a lecturing avatar for Brendan Kurbis, a research scientist at Georgia Tech School of Public Policy and a partner in the Internet Governance Project. Today, I'm going to share with you a research paper developed with the support of the George Mason Program on Economics and Privacy. In it, the authors develop a concept, data enclosure, and attempt to empirically analyze the impact of it on market competition. Data enclosure is the process by which information about user activity generated by digital data are withdrawn from an open or shared arrangement with other operators and made more exclusive to the service providers whose operations generate the data. We make the case that data enclosure is emerging as a significant feature of the multi-sided markets of digital platform providers. It reflects ongoing competitive struggles over the value, utilization, and protection of the vast amounts of user behavior data generated by digital infrastructure. Data enclosure is fundamental to current internet policy debates, being relevant not only to privacy policy and data protection law and regulation, but also to concerns about platform competition. Firms are not just responding to users' and governments' concerns by enhancing privacy. They may also gain a competitive advantage by excluding their competitors or other players from access to data generated by their users. Any realistic appraisal of the platform economy must look at both sides of this equation. To help illustrate the data enclosure concept and its potential impact, we look first at the encryption of DNS queries using the DNS over HTTPS protocol, or DOE. Then we examine the restriction of usage of mobile advertising identifiers in cross-app user tracking. Both of these are not only user privacy-enhancing moves, but also a means by which service providers compete with each other over the value and security of data. Data is often reified as the resource of the digital economy, but this can be misleading. The view of data as a static commodity obscures the operational and business reality of the platform economy. Data is an input into a service production process which contributes to the matching and monetization algorithms of a platform. Platforms function as intermediaries between different groups to facilitate value-creating exchanges. As intermediaries, the business value of the platform depends less on lots of data and more than anything else on lots of users, just as traditional advertising-funded services do. Data just makes matching the different sides of the market more efficient. As both economists and even critics of the digital market economy have identified, data is co-produced. Contrary to the popular critique characterizing users as exploited, unpaid data producers, a mutual economic benefit underlies the user-platform interaction. While user activities do provide inputs, without the platform infrastructure itself, there are no data and no useful applications for the data. This view of data is consistent with economists working out the logic of multi-sided markets, who have repeatedly demonstrated how it makes business sense for one side to subsidize entry or participation costs of another side. Enclosure is a way to create exclusive access to data, and thus raises the issue of property rights in information. In political economy, a property right denotes a form of control over a resource that assigns to the controller the right to benefit from it, the right to exclude others from those benefits, and the right to transfer. Exclusivity is the most fundamental feature of a property right. Without it, the other two features are less meaningful. In the abstract, digital data seems to resist exclusivity, seemingly a public good. But this fails on two counts. First, it would mean that large amounts of PII and users' behavioral data are unprotected and freely appropriable. Thus, any argument for privacy in the digital world necessarily involves some form of exclusion from access to data. Second, exclusion from data resources can and does happen all the time through legal, operational, or technical means. A simple historical example is the way encrypting TV signals changed satellite television from an open-access broadcast service to a paid subscription service. In the data enclosure initiatives we examine, platforms and other digital service providers are establishing de facto control over the data by technological and contractual means. Using these techniques, platforms withhold from others operational data generated by their users instead of sharing it. The term enclosure can have negative connotations, but we use it in a scientific, not normative sense, to describe a transformation of property relations that emerges as an institutional byproduct of market interactions. Note that the platform's control of the infrastructure allows them, not individual users, to assert the property right. They are the parties best positioned to gather and put to use the patterns generated by user behavior. A significant number of legal scholars concerned with privacy argue that platforms usurp the entire notion of a liberal market economy. They use this assertion as the springboard for proposals for radical transformations of the information economy, for example, the idea of data trusts. In our view, the emergence of data enclosure is a reconfiguration of property rights that is fully consistent with the operation of a liberal market economy. Moreover, it addresses some of the concerns privacy advocates have expressed and does so without the a priori, top-down, and likely unimplementable reforms proposed by the critics. Our analysis of data enclosure suggests that in a contested, multi-sided market, a digital platform provider competing for users would have two distinct incentives. First, an incentive to use the privacy and security of their users' data as a product differentiator. Second, an incentive to assert or maintain exclusivity over the data co-generated by its users and its infrastructure to maintain or increase a competitive advantage in the provision of intermediation. The product differentiation incentive and the exclusion incentive can reinforce each other, but sometimes they can work at cross purposes. Where better privacy is viewed as a competitive advantage, a platform would advertise superior data security for users, propose better privacy policies, or offer more secure operational techniques. Some platforms have clearly chosen this path. For example, Apple publicly brands its products and services as offering more privacy protection than its major platform rivals. In the other case, a platform may achieve a competitive advantage by generating and/or acquiring data that is different from, and somehow more useful than, the data possessed by its competitors. As suggested earlier, the best way to do this is to attract users that the other platforms don't have, and secondarily to expand the types of services bundled into the platform. In this case, the business would not have an incentive to share that data. It would deny its rivals access to data and users that it uniquely possesses. But, as we'll now see, that does not seem to be happening with DNS query data, although it may describe what is happening in mobile advertising identifiers, specifically on the Apple platform. Over the past decade, data privacy concerns led to the development of protocols to encrypt DNS queries, including DNS over TLS, DNS over HTTPS, DNS over QUIC, and oblivious DNS. These protocols, especially DOE, not only provide data confidentiality, but also disrupt traditional internet access and DNS query resolution relationships. Despite the challenges in tracking DOE adoption, available data indicates significant growth. According to AppNic, DOT and DOE query volume has risen fivefold in just over a year, increasing from 2.5% to 12% of total queries. More recent data from Cloudflare indicates DOE use in around 20% of queries. The competitive landscape is also changing due to DOE. Smaller competitors like Mozilla and Cloudflare are using DOE as a tactic against larger rivals, promoting it as a privacy and security advancement. DOE gives these smaller companies an opportunity to challenge Google's data dominance and impact its control over DNS resolution. However, in terms of market share, despite Cloudflare's DNS resolver usage increasing from 2.5% to 4%, Google continues to dominate, with its public DNS usage growing to 28%. Interestingly, Mozilla's Firefox, one of the first browsers to implement DOE by default, has seen its usage share decline. The data suggests that even though DOE may attract users for its privacy benefits, larger companies like Google can neutralize these gains by offering similar features. Thus, as of now, it appears the adoption of DOE has yet to significantly disrupt the market. In 2020, Apple announced changes to its identifier for advertising with the introduction of the AppTracking transparency framework, which required apps to obtain explicit user consent for personalized ads across apps. After the change in 2021, only about 20% of users opted into tracking, signaling a strong demand for privacy. The competitive impact of Apple's policy change was evident in the performance of Apple search ads. Before the iOS 14.5 launch, ad spending was fairly split between Android and Apple. Post-launch, iOS ad spend fell by 26%, with Android outpacing Apple, likely a result of some developers moving resources to a competing platform due to decreased targeting effectiveness on iOS. However, ad spending on Apple search ads recovered to around 40% as the industry adjusted and Apple introduced its own advertising network. By fall 2021, app installs linked to Apple search ads had doubled, attributing 60% of app installs on iOS to Apple search ads. Competitors were significantly affected. In the first quarterly reports following the change, social media platforms Facebook and Snap immediately blamed Apple's new policy for declines in revenues, with other sectors reporting similar results. In 3Q 2021, Facebook missed expectations due to a slowdown in the growth of their ad revenues. By mid-2022, Facebook reported, for the first time in a decade, that its revenues fell year over year. Apple, meanwhile, was benefiting from its changes. Its share of revenues from services grew from 14 to 22% in fiscal year 2021, with its strongest growth ever recorded. In the first quarter of 2022, Apple reached an all-time revenue record of $19.5 billion, up 24%, with all-time records for advertising among other services. Comparing market share in digital advertising before and after the policy change, Facebook's second-largest market share decreased by almost 11%. Meanwhile, Chinese firm ByteDance, encompassing TikTok and Douyin, recorded first-quarter revenues of $18.3 billion, growing market share by 74% and seemingly circumventing Apple's privacy enhancement effort. Other firms experienced minor growth, such as Alibaba and Google. Apple is not included in these calculations, but its in-app advertising sales were estimated at $45 billion in 2019, and its 2021 advertising revenues were estimated between $3 and $5 billion. Considering the remaining App Store advertising market of around $40 billion in Apple's plans to expand its advertising business, projections of up to $30 billion in advertising revenues by 2025 seem reasonable. This projection would place Apple among the top 10 firms for digital advertising revenues globally. In conclusion, Apple's privacy-enhancing change had clear competitive effects. Apple leveraged its user privacy enhancements to its own economic advantage, decreased competitors' market share, and positioned itself to influence the global digital advertising market. Hopefully, our conceptual development and analysis of data enclosure begins to illuminate the raging debate about the relationship between platforms, the market economy, privacy, and competition policy. If you would like more details about this work, we encourage you to download the full paper. Thank you for watching, and we'll see you next time.